Hi everyone and welcome. So in this video what we are going to cover is we are going to cover how to create your own Modbus TCP server in the Neuron to expose all data collected through any other data acquisition module within the Neuron. So if you have collected OPCDA data in the Neuron, okay, and if you want to populate or if you want to deliver the data over Modbus TCP protocol to any other Modbus TCP client, then you can deliver that OPCDA data to Modbus using Neuron by creating own Modbus TCP server in the Neuron. So that is possible. Okay, so that thing we are going to see in this video. So in previous videos we have already covered OPCDA client connectivity. Okay, so we have configured Neuron to connect with CAP server OPCDA server. We have configured Neuron to connect with metric and OPCDA server. Also we have configured Neuron to connect with the process OPCDA simulation server. And right now you can see here we are reading the data from process OPCDA simulation server, metric and CAP server. Okay, so I need to start the metric and services, but that's fine. We are reading the data from CAP server and the process OPCDA server. Now I want to transfer this data or I want to deliver this data on Modbus TCP protocol, okay, to any other client. Okay, and basically if you can say I want to convert OPCDA to Modbus, then we can do that with the Neuron. So here is the Neuron architecture. So basically we are reading the data from OPCDA server in the Neuron, and Neuron can deliver the data over Modbus TCP protocol to any other application and services. Okay, so how you can set that thing up, that we are going to see in this video. So we will create Modbus TCP server. We will map our OPCDA tag to Modbus, and with any of this software, either it can be SCADA or it can be Modbus, any Modbus client, we can read that data. So that thing we are going to see in this video. So basically Neuron can act as any protocol to any protocol converter. So in this video we will creating OPCDA to Modbus converter. So we are going to read the data from OPCDA server and we will deliver the data to Modbus. If you want to convert OPC-UA to Modbus converter, then also you can do that. If you want to convert MQTT to Modbus converter, then also you can do that. And if you want to convert BACnet to Modbus, then also it's possible. Also, if you want to convert Modbus serial to Modbus TCP, then also it is possible. Okay, so Neuron is that much capable. So let's see how you can do that. So here is our Neuron node running. You can see the process client tag value, and here you can see the CAP server client tag value. Okay, now we will go to the config section, and here in the modules we will create new module, which is our Modbus TCP server. Okay, and the module type is Modbus server. So you have to scroll down and here you can see the Modbus server. Okay, so I'm going to save it, and then after you have to navigate to the module Modbus TCP server, and here you have to create a new channel. It's our Modbus server channel. Okay, and we are going to save it. After that you can see the TCP port. So your Modbus TCP server is running on which port, that you have to specify here. The default port is 502. If you want to change it, then you can change it. And the Modbus mode we are going to select is Modbus TCP, because what I have told you in the starting of this video, that we are going to create Modbus TCP server in the Neuron, okay, which can expose all the data collected through any other data acquisition module. So that's why we have selected Modbus type is TCP. Okay, now the network interface we have to select. So your Modbus TCP server will run on which network interface, that you have to select here. So here I'm going to run my Modbus TCP server on my Wi-Fi network interface on this IP address. Okay, so I am going to select this one, and that's it. Now maximum connection, so we are going to allow the maximum 20 connection. Okay, so that's it, we can save it. After that we have to create a device inside it. So click on this three dot, click on the new device. Okay, and it's our Neuron Modbus TCP device, and you can expand it. Enable data collection, yes. Okay, and Modbus address offset is 0 and the slave address is 1. Now I'm going to leave the buffer size as it is, swap details as it is, status control as it is, and we have to focus on the map groups. Okay, so here we are going to create new tag map group. Okay, so I'm going to name it as a tag map group, and we are going to save the project. After that, we will expand it, and here we can see the tag map. So we have to map OPCDA tag to our Modbus TCP server, which we are creating in the neuron. Okay, so here you have to expand it. You cannot see any tag mapped. Okay, so I'm going to create a new tag map. It's my cap server tag 1. I'm going to map here, and we can expand it. Now you can see the tag. So here you have to attach which tag you want to map with this name. Okay, so I'm going to click here in the cap server client tag. I'm going to map this tag 1 to here, and the field is value, so we are going to pass the value field. Now this tag value you want to populate on which Modbus address, that you have to specify here. So I want to populate that tag 1 value to 4005, or you can say fifth holding register. Okay, and I'm going to save it. Okay, it will restart the module. That is fine. Now that's all we have to do. Okay, so now we have successfully created Modbus TCP server inside the neuron, which can deliver OPCDA data to Modbus protocol. Okay, and now we are going to test it. So in the real time, here you can see tag 1 has a value of 1558 and it is continuously increasing. Okay, so now we have successfully started our Modbus TCP server. So I'm going to open this Modbus TCP client, which is ModScan. Okay, so this will act as a Modbus TCP client. And if you go to the config section, here you can see the Modbus address we have selected is 40,005. So it's our holding register, correct? So in the client, I'm going to select holding register. I'm going to select length 10. Okay, and in the connection, we are going to press on connect, and the IP address I'm going to provide is this one, network interface IP address. Okay, and yeah, the port number is 502. As you can see, we have started our server on the port 502, so that's why I have to specify the port 502, and then I'm going to press OK. You can see the value 1612, and here also in the real time you can see the value 171819. Okay, so this value is available here. Now if I write something on the tag 2, suppose 107, okay, and if I apply it, it will take 5 seconds to update. Okay, because we have update interval 5 seconds. So you can see it's 107. Now I want to link this tag to 40,006. Then how can I do that? Okay, so whenever you update anything here, that should be available here. Okay, or if I update this value from the cap server, then also it should available here. So we have to map this tag to our Modbus TCP server, which we have created inside the neuron. So again, you have to go to the config section, and here we have to again create a new tag, okay, which is my cap server tag 2. And here also I have to assign the tag. So I'm going to assign this tag 2 for cap server client tag. The Modbus address is 40,006, and that's it. I can save it, and here you will see 107. Okay, it is restarted, so that's why connection got break. Now we can reconnect again. You can see 107. Okay, in the real time also you can see 107, and if I change some values to here like 502, and if I apply, then it will take 5 seconds to apply because the sync interval is 5 seconds. Okay, you can see 502 502. Now if I open my cap server, okay, then also we will update this tag value from the cap server, and we will see the update in the Modbus client. So let's wait for a few seconds until my cap server got opened. Okay, so here is our cap server. I'm going to launch the quick client here. Okay, our tag is under the channel 1 and device 1, and here you can see the value 502. Now I can do the synchronous write, and I can write the value 606, and I can hit the apply button, and I can press OK. Now 606, so it will take 5 seconds to update here, and once it got update here, you can see the update here. Now let's try to reverse it. Okay, we will update the value of this tag 2 from ModScan software. Okay, I mean from any Modbus client, and we will see that value is updating on the cap server or not. So I'm going to double click here. I'm going to write 1020 and I'm going to update it. You can see the value is updated in the neuron also and in the cap server also. So we are able to read OPCDA tag in the Modbus client as well, and from the Modbus client we can write something to the OPCDA as well. So it's a bi-directional communication. Okay, if I want to write something else like 52, and if I update here, then it will take few seconds to update here. Okay, you can see 52 got updated here, and in a few seconds it will also update here. Okay, so this is how it is working. Now you can change the scan rate of this tag to make it faster. Okay, right now it is taking 5 seconds to update, but you can change the scan rate. Now if you want to change the scan rate of this, then you can go to the config, you can go to the OPCDA, you can go to the tag. Okay, here you can see cap server client tag, and for the tag 2 you can config scan rate 1000 millisecond. Okay, sorry, for in the source, in the config, the scan rate 1000 millisecond, and we will save it, and we will go to the real time again. Okay, now if I change the values from here like 22, then it will be faster. You can see 22, 22, and yeah, I'm sorry, here also it will be 22. And if I change again from here like 66, then it will be very faster at every location, because previously we have 5 seconds of time interval, or you can say the scan rate, to update the values, but now we have 1 second of scan rate to update the value. So it will the value will move faster to each application. Okay, so this is how you can create your own Modbus TCP server inside the Neuron to deliver the data to Modbus client applications. Okay, so you can get the data in the neuron from any of this method. Okay, you can connect ABB PLC, you can get the data from CSV, and then after you can transfer that data to Modbus TCP server, and your Modbus TCP client can read that data, or any other SCADA system is attached to that, then that SCADA system is also able to read the data from neuron. So this is the power of neuron. You can convert any protocol to any protocol. So that is, I mean, I loved it. Okay, so you can see that we are running cap server. The cap server is updating the values, neuron is reading the values, and neuron is transferring that value to Modbus TCP server, and Modbus TCP client can read that value, and also Modbus TCP client write something to the neuron, and neuron can write that value back to the OPCDA server, and OPCDA server can accept that value, and the value got updated. So that's possible with the neuron. And if you want to add few more tag, then now if you want to add few more tag in your Modbus TCP server, then you can add few more tags here. Okay, so if you want to add process OPCDA simulation server tag, then also we can add it. So new tag, it's my process integer tag. Okay, I'm going to expand it. The tag I'm going to select is process client tag, PS integer 1. The Modbus address is 40,007. Okay, and I'm going to save it. It will restart, so it will disconnect, and I'm going to connect it again. You can see the 78, 82, and in the real time also, for you can see 80, 95, 1, 95, 45, 52. Okay, so those are in sync. Okay, so we can also transfer multiple OPCDA data to Modbus TCP server, which is running inside our neuron. So everything is possible with the neurons. Okay, so I hope this thing is clear, that how you can create your own Modbus TCP server in the neuron to expose all the data collected through any other data acquisition module. It can be OPCDA data acquisition module, it can be Modbus serial, Modbus TCP, OPCUA, or it can be MQTT, or it can be any PLC as well, or it can be CSV, XML, anything. Okay, so that thing is possible. And if you still have any question or any doubt regarding this, then you can always pin me on Telegram, Instagram, WhatsApp, anywhere. I'll help you in this. Also, I'm going to share this backup with you. Okay, yeah, after this video you will have the backup of this node below this Modbus TCP server. Okay, so you can download that backup and you can try by yourself too. So stay tuned for the next video, and if you still have any question or any doubt, then you know where to ask. So we are going to meet you in the next video. So till then, take care, goodbye, and thank you.